Hello friends, I welcome you in lecture number 28 on group theory. In this lecture we are going to discuss this question about inverse of permutation, and this question was asked in GTU Winter 2020 exam. If you remember, we have discussed about permutations in lecture number 8. A permutation on a set S is a function from set S to itself denoted by small p, and this function is 1 and onto. A 1 and onto function from a set S to itself is called a permutation, and we have discussed about permutations and permutation group in detail in lecture number 8 on group theory. So if you have not seen that lecture, I suggest you to watch that lecture number 8 first and then go for this lecture. Now we know that permutation is a function from one set to that set itself, which is 1 and onto. Therefore it is always invertible, that is its inverse always exists. And sometimes they ask you to find out inverse of this type of permutations. So we will see how to find out inverse of this permutation. And here this upper row contains 4 elements. So this permutation will be a function from set S to itself, where set S will be set containing these 4 elements 1, 2, 3 and 4. And we know that if S is a set containing n elements, then there are n factorial permutations possible of that set. So that set is important. If set has n elements, then there are n factorial permutations possible, and set of all permutations is denoted by Sn, and it is known as permutation group. We have already discussed about this permutation group in lecture number 8, so you should watch lecture number 8 first. Here we will focus on how to find out inverse of this permutation. So first we denote given permutation by small p. Let small p is denoted by 1, 2, 3, 4, 3, 1, 4, 2. And we want to find out another permutation which is inverse of this permutation. So and we suppose that inverse of this permutation is q. So we don't know what is q, but we can write q in this way. This is always 1, 2, 3, 4, and here we assume that suppose image of 1 is a1 under q1, image of 2 is a2, image of 3 is a3, and image of 4 is a4. So we assume that q is inverse of given permutation p. Okay, if you are not familiar with permutations, again I repeat, I strongly suggest to watch lecture number 8 first and then go for this lecture. Okay, fine. So now because q is inverse of p, we know that their composition must be identity permutation. So therefore composition of p and q either from left or right must be equal to identity permutation. Identity permutation, we know that image of 1 is 1, image of 2 is 2, image of 3 is 3, image of 4 is 4. So if p and q are inverses of each other, their composition must be equal to identity permutation. So now we can use this fact. We can use this one. We write that q composite p equal to 1, 2, 3, 4, 1, 2, 3, 4, and we use this fact to decide our inverse permutation q. So therefore now here we write permutation q, which we have assumed as 1, 2, 3, 4, a1, a2, a3, a4, and here we write given permutation 1, 2, 3, 4, and it is given as 1 2 3 4 3 1 4 2. So here we write 3 1 4 2, and this is equal to identity permutation 1 2 3 4 1 2 3 4. Now if you recall, in lecture number 8 we have discussed how this operation is defined. So we will start from this element. Image of 1 is 3, and here image of 3 is A3. So 1 is going to 3, and here 3 is having image A3. So this is the way how we have discussed composition of permutations in lecture number 8. So 1 is going to 3 and 3 is going to A3. So here I will write A3 below 1. Now 2 is going to 1 and 1 is going to A1. So here I will write A1. Now 3 is going to 4, and we can see 4 is going to A4. So we write A4 here. Similarly, image of 4 is 2 here, and image of 2 is A2 here. So this is A2, and this side is 1 2 3 4 1 2 3 4. So we have two equal permutations. Now two permutations are equal if these entries are equal. So from this we can say that A3 equal to 1, second entry A1 equal to 2, A4 equal to 3, and A2 equal to 4. So we have obtained values of A1, A2, A3 and A4 which we were required. So therefore inverse of P, which we have assumed as Q, is now 1 2 3 4. A1 is 2, A2 is 4, A3 is 1, and A4 equal to 3. So this is the inverse of given permutation T. And if we wish, we can cross check, we can multiply these two permutations P and Q, and our answer must be identity permutation. So I hope you understand how we have obtained the inverse of given permutation. First we assume that suppose Q is the inverse of given permutation. So we don't know this image is for Q, so we assume that image of 1 under Q is A1, image of 2 is A2, image of 3 is A3, image of 4 is A4. Then we use the definition of inverse. Because P and Q are inverses of each other, their composition must be equal to identity permutation. Now we are using this fact, Q composite P is identity permutation. So now we apply this composition between Q and P, and then we are able to find out values of these A1, A2, A3 and A4. So in this way we can easily decide the inverse of given permutation. And here you can see, I will show you that our answer is correct. Okay, this finishes your answer in examination. This is just for cross check. So now we can multiply, or we can take composition of P and Q, and if our answer is correct, we must have identity permutation as a resulting permutation. So Q we have obtained is 2 4 1 3, and let me see what is given permutation P. It is having images 3 1 4 and 2. So here we write 3 1 4 and 2, and if we take this composition, our answer must be identity permutation. So as we know, we start from this. Image of 1 is 2, and then we go for here. Here image of 2 is 1, so here we write 1. Then 2 is going to 4 here, and here 4 is going to 2, so that is 2 here. 3 is going to 1, and 1 is going to 3, so here we write 3. 4 is going to 3 here, and here 3 is going to 4, So this is nothing but identity permutation. So our answer is correct, that this Q is nothing but inverse of given permutation. So sometimes they can ask this type of question. They have asked this question in GTU Winter 2020 exam. So I hope you understand how to find out inverse of given permutation, and with this I stop this session. Thank you very much.